Good morning, middle one. Today we are going to talk about Unit 1, Lesson 1 of the chemical combination. First, you have to know that all element that we have discovered it until now is 118 elements. So we need to classify all these elements into metals, nonmetals, and noble gases. First, we have a comparison between metals and nonmetals. The first point of comparison is the luster or shining. First, the metals they have luster or they are shiny. The nonmetals they don't have luster or they are not shiny. Second point is the conductivity of the heat. All the metals are good conductor of heat, but the nonmetals are bad conductor of heat. The third point is the conductivity of electricity. First, the metals they are good conductor of electricity, but nonmetals they are bad conductor of electricity except carbon, which is the only nonmetal which is good conductor of electricity. The fourth point is the state at room temperature. First, metals. All the metals are solid except the mercury, which is the only liquid metal. And about the nonmetals, all of them or some of them are solid. The rest are gases, and we have only liquid nonmetal, which is the bromine. The fifth point is the malleability or the hammering. All the metal can be hammered to form sheets, or I mean that they can be bent, but non-metals they can't be hammered or can't be bent. The last point is the number of electrons in the outermost energy level. All the metals contain one or two or three electrons in the last energy levels, which I mean they contain less than 4 electrons in the outermost energy levels. The nonmetals they contain 5 or 6 or 7 electrons in the outermost energy level. I mean that they contain more than 4 electrons in the outermost energy level. And if we talk about the levels to the metals, the electron in their energy levels. So I mean that the electrons are distributed in their levels. And in the nonmetals too, the electrons are distributed in their energy levels. If we talk example about the metal, we will find the gold, aluminium, and mercury, which is the only liquid metal. And if we talk example about the nonmetals, we will find sulfur, oxygen, bromine, which is the only liquid non-metal. Now let's talk about the behavior of the metals in the chemical reactions. All of you know that the metals contain less than 4 electrons in the outermost energy levels, which I mean that they are unstable and active, so they need to be active. So the only solution for the metals is to lose their outermost electrons and change into positive ion. Why the metals change it into positive ion when it loses electrons? Because the number of positive proton will be more than the negative electrons. Okay, now I need to know that what is the charge of the metal, what is the charge of the ion when it loses electron. For example, if a metal loses one electron, so the charge will be only one positive charge. If it loses two electrons, so it will be positive two charges, and so on for the three electrons. So I mean that the positive charges in the ion equal to the lost electrons. If we talk example to apply this idea on it, we will take the sodium atom, the magnesium atom, and the aluminium atom. First, we'll talk about the sodium atom. The atomic number of sodium is 11. So if we make the electronic configuration of sodium, it will be K2L8 and M1. So the sodium will lose its outermost electron, which is the 1, and change it into sodium positive ion, which its electronic configuration will be K2L8, which is a stable form of sodium. Next, the magnesium. The atomic number of magnesium is 12, so the electronic configuration will be K2L8M2. So the magnesium will lose its outermost electrons and change into magnesium positive ion, which carry positive 2 charges because it lost 2 electrons. And the new electronic configuration of the ion will be K2L8. Finally, the aluminium atom. The aluminium atom, its atomic number is 13. So if we make the electronic configuration will be K2L8M3. So the aluminium will lose its outermost electrons to be aluminium positive ion, which carry 3 positive charges because it's lost 3 electrons. And the new electronic configuration of the ion will be K2L8, which is a stable form of aluminium. Now we will talk about the nonmetals. First, all of you know that all nonmetals contain more than 4 electrons in their outermost energy levels. So, I mean that they are active and unstable. So they need to be stable, and the only solution for the nonmetals to be stable is to gain electrons. Gain electrons which is lost by the metals. So when the nonmetals gain electrons, they change into negative ion. Why? Because the number of negative electrons will be more than the positive protons. Okay? Now I need to know the number of charges which is carried by the negative ion. For example, when chlorine atom gain 1 electron, it only gain 1, so it will carry only 1 negative charge. So the number of negative charges in the negative ion will be equal to the gained electrons. We have some examples to apply this idea on it, which is a chlorine atom, oxygen atom, and a nitrogen atom. Let's begin by chlorine atom. The atomic number of chlorine is 17, so the electronic configuration will be K2L8M7. So it will gain 1 electron to be a negative ion, and its new electronic configuration will be K2L8M8, which is a stable form of chlorine. Next, the oxygen atom. The atomic number of oxygen is 8, so the electronic configuration will be K2L6. So the oxygen will gain 2 electrons to be oxygen negative ion, which carry 2 negative charges because it gained 2. And the new electronic configuration will be K2L8. In the nitrogen atom, the atomic number of nitrogen is 7, so the electronic configuration will be K2L5. And this atom will gain 3 electrons and change into nitrogen negative ion, which carry 3 negative charge. That's equal to the number of gained electrons. And the new electronic configuration will be K2L8. Now to summarize all this topic, you have to know what's meant by positive ion. The positive ion, it is the atom of the metal which lost an electron or more during the chemical reactions. And the negative ion, it is the atom of the nonmetal that gained an electron or more during the chemical reaction. For in general meaning, the ion itself is the atom of element, maybe metal or non-metal, that loses or gains an electron or more during the chemical reaction. Now let's talk about the noble gases or the inert gases. You have to know that all noble gases or inert gases are completely filled with 8 electrons, except helium, which has 2 electrons. So they are inactive and they needn't to make any chemical reactions. I mean that they will not form a positive or negative ion in the ordinary conditions. So what's meant by noble gases? They are elements that don't enter or participate in the chemical reaction because they are completely filled with electrons. Now let's talk about the chemical bonds. You have to know that the atom combined with each other by bonds. So we have many types of bonds. First type of ion is the ionic bond. The ionic bond always arises between the metal atom and non-metal atom. I mean that the metal will lose its outermost electron and give it to the non-metals to be stable. We have here examples on the ionic bond and their compounds. The first one, how sodium atom react with chlorine. You have to know that the sodium is metal and chlorine is non-metals. So they react together by ionic bond. First, the sodium atom loses an electron from its outermost energy level to be positive ion. And the chlorine atom will gain the electron which is lost by sodium to be negative ion. The positive sodium atom, the positive sodium ion will react with negative chlorine ion to form sodium chloride. So if I ask you about the bond inside the sodium chloride, it will be ionic bond. By the same way, the magnesium oxide will be happened. The next bond is the covalent bond. The covalent bond always arises between two nonmetals, which each atom share by number of electrons that need to complete its outermost energy levels. For examples, we have three types of covalent bonds: single covalent bond, double covalent bond, and finally triple covalent bond. Let's first talk about the single covalent bond. The single covalent bond is happened between two nonmetals which each atom share by one electron only. Example, in the hydrogen molecule, each hydrogen atom share the other by one electron, so the bond inside the hydrogen molecule is single covalent bond. Now let's talk about the double covalent bond. It is the bond that happened between two nonmetals which each atom shares by two electrons. Example, in the oxygen molecule, each oxygen atom shares the other by two electrons. So if I ask you about the bond inside the oxygen molecule, it will be double covalent bond. And finally, the nitrogen bond. Finally, the nitrogen bond, which is an example for the triple covalent bond. What's mean by triple covalent bond? It is a bond between two nonmetals which each atom shares by three electrons. Example, in the nitrogen atom, in the nitrogen molecule, each nitrogen atom shares the other by three electrons. So if I ask you about the bond inside the nitrogen molecule, it will be triple covalent bond. You have to know that we have compound called water. The water is H2O, two atoms of hydrogen and one atom of oxygen. And inside this compound, there is two single covalent bond. So if I ask you about the bonds inside the water molecule, it will be single covalent bond.